morning, everybody. Good to see you all. And it's true, I am going to talk about the 3 pillars of open source AI. Just a very quick background on myself. I got involved in open source about 20 years ago. And about 15 years ago, we started a project called OpenStack, and shortly after, a nonprofit foundation, which became the Open Infra Foundation. And we raised about $150 million, which turned into a multi-billion-dollar industry. And these days, $150 million will get you like an engineer, AI engineer at Meta. But at the time, it seemed like a lot of money. But we invested it in the community and built an ecosystem today that's in the billions of dollars. And today, I am the GM of AI and infrastructure for the Linux Foundation. This is a pretty new development. And my mission is really to try to do everything we can to make the AI era, the intelligence layer, open the same way we fought in the cloud to achieve the same. And the reason I joined recently is because we joined our foundations together. So the Linux Foundation and Open Infra Foundation have combined just a couple of months ago. And this really brings together 3 of the most critical foundational open source technologies in the world: Linux, OpenStack, and Kubernetes. And these projects already are powering data centers all over the world. They're very commonly used together, and they sit at different layers of the stack, and they're highly complementary. And we have a thing we call the Open Infra Blueprint, where you can read about all the users and how they're combining these 3 technologies. Now, I am here to talk about AI, not just infrastructure, but the reason that I'm working on these together, and I encourage you to think about them together, is because you actually can't separate AI from infrastructure. Sometimes we think of them as different domains, but they're really highly connected. And if you look at what AI is doing to the infrastructure world, the biggest providers in the world like Google that have massive data centers, they're recently disclosed they're processing 1 quadrillion tokens per month, which is 100 times more than 1 year ago. So I think there's a lot of hype in AI, but I think it's not just demos. This is a real production workloads at an insane scale. And if you talk to people about the challenges they have in embracing AI, most of them come back to infrastructure, like can't get enough GPUs, power sources, latency, data gravity, et cetera. So it's important that we think about this holistically if we want to see a world where this powerful technology is truly open at every layer of the stack. And inference is something I'm going to talk more about today, but one of the things that people are often interested in is how much energy does all this use, and how can we make it more efficient? And Google recently talked about how they were able to reduce the energy per prompt or per token 33x in just 1 year. So the pace of change, if you feel like it's kind of hard to keep up, the numbers back up your feelings on that one. It is hard to keep up. Now, if we look at open source across these 3 pillars, one of the reasons why open source is winning, or certainly highly competitive, is because, as the founder of DeepSeek said last year, these moats that closed source labs have, closed source providers, they're very, very short-lived. And at the time, I'm not sure how many people believed him. But he quickly did launch DeepSeek a few months later with the R1 release, and I'm sure everybody's quite familiar with that. And it quickly shot up the charts as one of the fastest growing, most downloaded open source model in the world. And if you look at the data, it does show that the open weights models, the open models, are quickly catching up. In some cases, even are state of the art. But this, is a back and forth game. Every day, it seems there's a new model. But I think it shows that anyone who thought the closed models were going to win and that the game was over were dead wrong. And speaking of which, as an example, I think back in February, after DeepSeek kind of shook up people's expectations, Sam Altman said, I think we might be on the wrong side of history here. And just a few weeks ago, they went back and released a couple of open models, and that was something they hadn't done in years. So it shows that there's intense competitive pressure. Open source really does bring out the best in the industry. It helps us all move faster. And what's interesting, too, is they have a 120 billion parameter model, but also a $20 billion parameter model. So another trend that we're seeing is small models. These are really important for all kinds of different use cases, especially at the edge, but if you want to run it on your laptop, there are many different ways you can do that. And there's a lot of innovation in how you shrink a large model down and not lose a lot of the capabilities. So as we see this open layer across the ecosystem continue to advance the frontier, it does provide a lot of fuel for the growth of the industry, and people are able to build businesses on top. And that's a trend we've seen over and over again with open source, and I think it's going to repeat once again. Now, I promised you that I would go through the 3 pillars of open source AI. This is just kind of how I've broken it down. It helps me think about the state of things and where there's more work to be done. And I think what's interesting about this is that each of these has a little bit different open source community, a little bit different state of progress and maturity. You know, training is simply getting some great high quality data and running your training runs and producing a model. That's grossly simplifying what it is, but the tool sets are actually quite mature here. PyTorch has 80% market share. There are a lot of other open source tools that have been used for many years. And of course, there are other alternatives to PyTorch as well. But the point here is really, it's fairly mature. Now, you may have to have a gigawatt data center and convince Jensen to give you racks of GPUs. So there's other constraints here. But from a software perspective, there's a lot of progress here. And the PyTorch Foundation has done a great job at helping advance this pillar. Now, inference is at a little bit of a different stage. So if training is where you build the model, inference is running the model, basically serving it. And there are lots of inference frameworks for doing the serving of the models. And it's a highly competitive space. There are many, many competing tools here. There's VLLM, probably the most widely adopted, but there's also SGLang, and there's AI Bricks, which is powered, which is from ByteDance. It powers a little app you might have heard called TikTok, or ask your kids about that. It's pretty high volume. So there's a lot of competition and innovation happening here. And this is a very exciting time because, as I said before, the inference is, if we can make it more efficient, it'll use less energy. It's also just how AI goes to market. I think inference is the largest workload in human history, and we're going to see how it reshapes the infrastructure in all the ways we interact with it. But the flip side in this phase of an open source ecosystem is that it's a lot harder for users to just know what to take off the shelf and run. So as a community, as an open source community, we have a lot of work to do. It reminds me a lot of the early cloud days with OpenStack, when it was much harder to kind of get all the dependencies worked out and know which configurations to pick. And then agents, you probably all heard of agents. It's kind of a buzzword right now. It's a little bit hard to define. You could say any piece of software that calls a model is agentic, and certainly lots of people are putting agent on everything because they want to seem like they're on the cutting edge. But it's really about protocols primarily. These are standards that we really need to see solidify so that we can be sure that it's secure and interoperable. How many of you have heard of MCP? Yeah. So it's got a lot of awareness, and it's moving rapidly, and there are a number of other pieces as well that are coming on the scene. And sometimes it does feel like we're just, slapping the word agent on cron jobs and rebranding them, and suddenly everything's an agent. Now, if you don't know what a cron job is, congratulations, you have no gray hair. I can't say the same. I know a lot about cron jobs. Okay, so I better wrap up here. But when we talk about agents, there's a lot of hype. And I think it's important. Andrej Karpathy is talking about how agents are going to change how we do software. Trillions of lines are going to get rewritten. So it's more useful to think of it as a decade-long project. And for something like this, the sooner we work together in the open, the better. Because we are never going to get the promised land of agents without cooperation, standards, and open source. And if you think about the coding agents, this is a hot topic. Some people say, in a few months we're going to be able to just fire up a bunch of agents and fire all of our employees. It's every CEO's dream, right? But it's not reality. You have some examples where a lot of code, lines of code, are being produced with Google quoting 30% and so forth. But the CEO of Amazon Web Services just said that the idea you're going to just replace wholesale your junior developers is, I think he said, quote, one of the dumbest things I've ever heard. So it's possible for both of these things to be true, in that these are very powerful tools. They're helping make developers more productive. But it's far from just being a human replacement. So I think we're very early days. And when we think about what's needed or what's different about this type of ecosystem, security is massive, discovery, trust. These are all things that open source does better. In fact, I would argue there is no way to achieve the vision of agents without open collaboration, open community. And the last thing I will say is just that if you think about the communities themselves and kind of the size of the community and the number of people in it, I think this is a useful illustration. So the training community is just much smaller by number of people that are training, say, frontier models. Doesn't mean it's less important. You can't do anything on top of that or with those technologies without the training. It's actually highly leveraged because it is a small group of very dedicated people training models, pushing the frontier. When it comes to inference, that's more of a little bit more mainstream in terms of running the models, and you need a broader set of people to run them in production and data centers all over the world. And also, I think it's more critical to think about service levels, because if your training run goes down, you can restart the training run. If your inference goes down, your customer experience, your business, your bank could be suffering. And then as we get to sort of the app layer where we connect all these things, it's going to be even bigger. Similar in the web world, we have back-end frameworks, and then when you get to the front end, there's a new JavaScript framework every 2 days. So it's just simply more people, and as we form the communities and events and gather people together, it's helpful to think about kind of some of the differences. They're interconnected, but they're going to be a little bit different set of people. And the Linux Foundation already hosts a number of key open source projects that make this movement possible. But there's a lot more out there that's getting created every day, and we really want to help build those communities so that we can make training, inference, and agents successful in the open. So that's what I've got for the opening, but I do want to bring out a few special guests to talk more about some of these projects. And the first person is Easy Lanza, LF AI and Data TAC Chair, and he's going to talk a little bit about the LF AI and Data Foundation. Come on out.
Hi everyone. Today I'm going to talk about what we've been doing over the last year on the LFI and data, and also I'll be talking about some cool projects. So the first slide that I have to show is about the members. The LFI and data is an organization itself because of its members, but I don't see as just one slide that talks about logos. I see way more than that. I see that multiple companies, big companies, small companies, researchers, they all sit in the same table to build something, or to build AI, or to advance in AI. So that makes that the vision is to keep AI open, to make sure that no single company owns the future of AI. And that's very important now when we are talking about agents, AI, development, and everything. And the mission, that makes that our mission will be to advance, and it is, to advance open source AI. But making sure that it does go a bit beyond the hype. We are talking about agents, we are talking about AI, there's a lot of buzzwords, there's a lot of hype when we talk about AI, but the LFI and data is focused on deliver actual real-world impact. When we talk about real-world impact, we are talking about organizations, how we use those technologies, how organizations are actually using the technology, and that's about using, they don't want to use faster models. Even though we love to talk about the models, they just want to use faster models. They want to use AI they can trust, they can use, they can own, and they can adapt to their own values. And that's what sovereign AI is. So sovereign AI is about transparency, ownership, and independence. And those organizations, they are relying on the open source to build their own custom applications, their own custom AI. And that's very important to mention when we talk about the challenges that they face. They are using AI, and they are building their own custom applications, and they face a big challenge when they are talking about AI, which is the data quality. I didn't make up those numbers. Those numbers came from a study, part of the Sovereign AI, that was published, I think, 2 days ago or 3 days ago. So if you'd like to take a look, please scan the QR code. And following on what Mark mentioned about the pillars, I would like to talk a bit about the projects. We have the three pillars. We have training, inference, and agentic. But we also have a big pillar that is the data that is crossing about everything. It's about Docklin, to train your data, to process your data. It's about the Melvos, also data lake. You have lakes, you have vector embeddings, you have databases, and these are cool projects that you can use. For training, you would like to ensure that you can use the distributed training, and tons of things related with training. Inference, the deployment. Cloud Native has a lot of things to do here. There's a lot of synergy with Cloud Native project. Opia, Flight, you need to orchestrate those AI workflows. The security, you would like to understand how this model works, and you need to have the model interoperability. That's why Onyx is a very good project on that, IRI, NNN Streamer, how you run those projects in the edge, for instance. That's very important. And Agentic, we have a very new project, BAI, that is a cool project. We talk about the framework. We talk about MCP, ACP, A2A, but we are actually thinking on, we need to have a framework to use an agent independently if it's MCP, A2A, or agent to agent. It's not just about the project. There are working groups that people, experts from the industry, they meet together to define standards and to define policies or to define things that it cannot be done by a single individual. So if you would like to be part of the Linux Foundation, you can contribute to those projects. I just mentioned a few, but there are 50 projects that are part of the Linux Foundation. So you can be part, you can contribute. You can join to the working group. If you're an expert in security on some of those topics, you can be part, or you can partner with the foundation. So thank you for your time, and enjoy ADF. Thank you.
All right. All right, thank you. Easy. Now, we've been talking about how there's a lot of hype in AI, and I love hype, but also it's important to talk about real-world use cases, and nobody's doing more impressive stuff at crazy scale and breaking the science barriers like Ricardo from CERN. So come on out, and I think he might even have a demo, so pray to the demo gods.
All right. So hello, everyone. My name is Ricardo. Thanks, Mark, for the introduction. So I lead the cloud native and machine learning platforms at CERN. I hope CERN doesn't need any introduction, but just for context, we have a large particle accelerator where we accelerate protons to close to the speed of light, very high energies, and then we make them collide in these gigantic instruments in the ground. And these instruments are particle physics detectors, but they act as pretty much gigantic cameras taking 40 million pictures a second. So this is the challenge we have. And this corresponds to a lot of data. So we're generating something like a petabyte of data per second on each of these experiments, and we have to reduce it to 10 gigabytes a second that we can store and analyze. And for this, we use what we call triggers, which are basically filters. And these filters are reducing, are basically dropping some of the events, and we start with this level 1 trigger, which is very low latency, very fast, and we traditionally use custom electronics and FPGAs for this kind of thing. And then we slowly go to like different computing farms, like CPU farms. These days it's more GPU-based as well, but this is how we handle our data, what we call online. Now, a lot of this is already using ML these days, but it's not a typical Gen AI. And we look at the very small, and it's an interesting comparison. LLMs would be the cosmology of AI, very large things. And what we are looking is the small, so we use small models. And these are real production deployments of ML in our stack. And this is from a survey from one of our experiments. You can see here on the bottom left. Our models, the small models are less than 1 megabyte, and the extra large models are 1 gigabyte or larger, which is kind of laughable if you compare to LLMs. But if you think about it, these are compressed models, but we want to deploy them in FPGAs, very low power, low resource devices. So we want them small and efficient, and we use tools like HLS for ML that we can contribute to, where we take the usual model formats and we convert them to these things that can be deployed in FPGAs. This is the event filtering. We also use ML already for simulation. Simulation is 90% of the computing at CERN. And we have ML models doing speed-ups of 2 orders of magnitude compared to the traditional ways we do simulation. So these are real things. Now, what's coming next at CERN is always bigger. So the next upgrade, an example from CMS, the input data will go from 2 terabit a second to 63 terabit a second. And they started measuring in percentages of the total internet traffic, which is really, really scary. And we have to make decisions on the 12.5 microseconds. So we need these very efficient devices. And then they start saying, OK, we are dropping 99% of our data. What if new physics is in this data? Can we drop less? So they ask for more. And then simulation data I mentioned, and you can see here the rise coming in the next couple of years in this needs. So this is all justified a new project called Next Generation Triggers, where we look at AI and ML to try to solve these problems. The traditional platform that we offer does all these steps. Everyone is more than aware of this: data preparation, analysis, and then some iterative prototyping, distributed training, tuning, and then eventually model storage and serving. But what's in our Swiss knife for machine learning? So these are the projects. I won't go into details. There's a lot more. These are just examples. But what I would like to highlight here is these are all open source projects, or most of them. And what we really need is that these projects are sustainable, because our experiments last decades. And we need to have communities and sustainability in this project. So it's very important to have the foundations under the Linux Foundation supporting these communities. But more than the projects, what we've learned is that what we need for our Swiss knife is a scalable hardware platform for training and inference, tool sets and services for all the things we want to do, but then also documentation and efficient use of the available resources. And this is something we learned, is that if we don't make it cost-effective and efficient, ML will not succeed. If you extend this Swiss knife, then you will see that you want to build expertise and optimization of ML workflows, and then you want to have courses to scale out for large organizations such as CERN, as people come to join. And then you need seamless access to new devices. These things are moving really fast. If you convince people to use a platform, you need to be able to onboard new things in that platform and not constantly make people look at different things. Now, with this, I will move to a demo, which let's see if it will work. OK. So this is a production infrastructure at CERN. We rely on Kubeflow for a lot of things. And in this case, we'll just show you. It's kind of the hub for everything we do. And like in Kubeflow, you can go and create your notebook, give it a name. And then you can choose your image. And we keep curated images with the versions and tools that people are expecting to use. And then you can select the number of GPUs. And you can see here the different GPUs we have. In this cluster, it's all NVIDIA-based. And then you can select other options that allow you to configure your environment. So this is the things that really need to be there to integrate with the existing environments. Now, I created a notebook in advance, which I will connect to here. And in this notebook, you will see that I have an environment where if I type here NVIDIA SMI, you will see that actually I'm using a partition GPU. So this is where efficiency comes. Like this is not a full GPU because I'm doing iterative development. And I will just open a notebook. And I will, because for most junior engineers, I would say notebooks are like the standard. So this is what they want to use. And I will do my reading of the input data, some pre-processing, and then I will launch my training. Now, this will run 100 epochs, so it would stay here for quite a while. So what I will do is you also need to give feedback to the people using the tools. So tensor boards are pretty popular, so I did a run before. And in Kubeflow, you can really have this nice integration. So once you've done your training, you can see some parameters of what the accuracy or the loss of your model has been, or your training. Not very good results, but it's just for the purpose of demoing. Also, in this same platform, we integrate the endpoints for serving. So in this case, we have one here that I created in advance. And you can see all the details. You can also launch the metrics and see what's running there. So what I will do is I will go here again to my, and I will just run here. So this is a model doing what we call data quality monitoring. And what I'll do, I'll just load some predictions to create some traffic. And you see here that they are running. And if I go, so this is live. If I go to to my monitoring, I'll start seeing here some details showing in the live metrics. Now, this is good for knowing what the models are doing. What we also offer is much more extensive monitoring of the resource usage. So this is that kind of dashboards that our users have access to, where they see the average GPU utilization, but they also can dig deeper into the CPU utilization and things like this. So if I go back to my dashboard, there will be some points showing up here in a second or so. Yeah, there you go. So you can see this is like running on a production infra, so it's all working right now. What you can also see is that originally I had one predictor running, so one instance of my serving. But as I triggered more trainings, you can see in the last 45 seconds, there were a bunch of instances being created, which shows that this thing is scaling automatically, which is what we want to do. Now, the interesting thing is that this is how new generations interact with the platform. Now, we have older generations, more experienced people that are less keen on using notebooks and friends. So we also offer them the possibility of using command line tools. And in this case, you can just create, if you know Kubernetes, you know how this works. It has a bunch of capabilities you want, and then it has the possibility of selecting the GPU. And I created a session, and if you're comfortable with Kubernetes, you will do something like this, and just get a shell in your container. And in this case, I'm actually using a different GPU type. I'm using an SXM GPU, and this is one important thing, is that if you're doing LLM specifically, you want to do multi-node training. So in this case, I'm usually using InfiniBand as networking internally. And it all works in the cloud-native world. So this was one of the main problems, is integrating this kind of HPC primitives that are required for LLMs into the cloud-native world. But this is now there. Now, the other thing that is important is that our users, some of them don't know Kubernetes and don't want to know Kubernetes. So what they want is to have seamless access to this kind of session. So what I'll do, I will just trigger, I will SSH into my workload. And this works exactly in the same way. So you can see now that I'm basically in the same place, same pod. And one thing that is also important is I mentioned the efficient use of the resources. And if you're using public cloud resources, you don't really have the control over this. But if you're using your own resources, you need to do things like CPU pinning, NUMA mapping. All these things are extremely important. And I will just trigger here a last bit, which is I'll trigger a training. And you will see that I'm loading. On the top, you see all the CPU cores available, and I'm loading very specific CPUs. I'm pinning the workload, not distributing fractions, which means that my workload is running on a controlled set of cores that are directly tied to the GPU. And this is where we gain something like 30% performance, and you can translate this into money, basically. And with this, I finished my demo. It was a very quick one, but I will stay here for the 2 days. So if you need more information and you would like to discuss all that I've shown here, I'm more than happy to follow it up. Thank you very much.
All right. Well, that was awesome. I love hearing from real-world production users, and Ricardo's always an amazing presenter, and I love the live demos. And he usually blames me if it crashes, so I'm glad that one worked. But you know what? I think he's doing training with small models, and he's doing inference, and he's really doing it in the real world. So it's great to hear how he's doing it, what tools he's doing it. And we've talked about training, we've talked about inference, and the wide world, crazy new frontier of agents. In order to talk to us about that, I have Lynn Sun here, the head of open source for Solo.io.
Thank you so much, Mark. Hi, good morning, AI Dev. It's so special to be here in Amsterdam with you all. So I don't actually have any slides, so may the demo god be with me today. All right, this is a demo application I actually been building myself. So I'm going to showcase Agent Gateway today with you all. And Agent Gateway, I have it running in my Kubernetes cluster. How many of you know Kubernetes? All right, awesome. I love that. And I have Agent Gateway deployed as part of programmed by a control plane called K-Gateway using Kubernetes Gateway API, which is the future of Kubernetes networking API. I also have Agent Gateway deployed myself, kind of doing it myself using deployment, and I'm deploying it in the default namespace. And I want you to serve it between my AI agent and also my MCP server. I deployed the GitHub MCP server myself. Also in this namespace, I have the demo application, which I just showed you, the GitHub repository, also deployed in this namespace. So let's try to visit the demo application. And I want to use Agent Gateway to access the demo application. So I have already set up everything on my machine to do port forwarding. So I believe I set up to port 8888. So that's hopefully, if everything goes well, it's supposed to show you my demo application. But unfortunately, there is a problem. I'm getting no healthy endpoints. So I'm going to try to, because I'm on stage, I'm a little bit nervous, so I'm actually going to try an AI agent to help me debugging this problem together with me on stage. So in order for me to debugging this problem, I'm also running an open source project in CNCF called K-Agent. And I develop a bunch of agent using a bunch of tools. Remember I showed you early on, I was deployed the MCP GitHub server. So as part of the MCP GitHub server, because I'm accessing it through Agent Gateway, I'm only exposed 7 out of 20, 30 plus tools of the GitHub MCP server. You can see these are the tools I exposed because these are the only tools I need for my agent. And then going to my AI reliability agent, you can see on the right side, I have the tools available from the GitHub. I also have a bunch of tools related to Kubernetes to help me troubleshooting the issues in the Kubernetes cluster. So what I'm going to ask the agent is the demo service in the default namespace cannot be reached from the agent gateway in the K-Gateway system namespace. Can you debug? Now, with AI agent, I don't know if the agent can do the job, but let's see. All right, can you guys see this well? Let me make it a little bit different. All right, so the agent is running a bunch of commands. You can drill in to see what the commands it's running. OK, it's getting the route configuration I have in my default namespace. It's trying to figure out the repository I have. And the reason the agent figure out the repository I have is because I have an Argo application, and I'm using Argo to push my application to my Kubernetes cluster. So based on my Argo application, the agent seems to be able to figure out the repository and also figure out the path of the repository, which is in the Kubernetes. All right, looks like the agent has an error when creating the pull request. Let's see. It sounds like the agent was able to create the branch, but somehow had a problem when creating the pull request. OK, so the good news, actually, the pull request might be created. All right. I guess the agent was lying to me. Let's go ahead and hit my repository and see if the pull request. All right, so the agent is actually working, but the status was not entirely correct. You can see the agent created the pull request 90, and the agent was fixing. Let's check if the agent was fixing. So this is 29. Sorry, I said 90 earlier. So 29, and if you go here, you can see the agent discovered the demo service was listening on port 80 instead of 88. So let me go to Sorry, let me go to my Kubernetes services just to confirm if the agent is correct, right? We do human in the loop when you work with AI agents, right? So if I go to the service here, you can see this service is listening on port 80 with the target port 8001, right? So if I go here, that looks right. It's pointing to the backend reference. So I'm going to go ahead, approve this request. And I'm going to merge this in. Hopefully, it would correct the problem I have. So right after I merge my code, I'm going to use Argo to sync the latest of my code into my cluster. And I'm hoping to refresh here. Everything actually works. All right, so this is the demo application I want to show you. Now, before I show you, I want to show you something really quickly so you understand how the agent is working. So what I was showing you is I had this AI reliability engineer that was troubleshooting the issue in my cluster. And this was talking to the GitHub MCP server through the agent gateway I deployed myself. And the AI reliability engineer was running as part of the K-agent framework. And it was also using external Google AI, which is Gemini, as my large language model. So it determines what to do when calling the tools. So that's the architecture I just showed you to debugging everything. Now, before I run my demo application, I'm also going to run my agent gateway, another instance of agent gateway outside of my Kubernetes cluster. And this is my agent gateway configuration to show you really quickly. You can see I have the OTel endpoint configured. I have the tracing enabled. I'm forwarding on port 3000 into my Olama, which is listening on localhost 11434. And here I can actually access the agent gateway UI here. Because I haven't got this running, sorry. So what I'm going to do is I'm going to do this configuration. So once I enable this configuration, I should be able to access the agent gateway UI, and I should be able to see what policy it has in here. And you can see when I select the policy, you can see I have a local rate limiting policy enabled. Now I'm going to set it a little bit lower so we can see if the policy is working. So I'm going to start with chat with Nama. We talked about MCP early on, right? So this model I'm interacting is a little bit old. So I'm going to ask it, what is MCP, and see what it says. So basically what the application is doing is going to go through the traffic sent before sending to the large language model. It's going to talk to the agent gateway, and then the agent gateway is going to forward the request to the large language model. You can see the model is very, very old. It doesn't know what MCP is for AI, Model Context Protocol. Now the next question I'm going to ask is, what is agent gateway? Now you can see I'm getting rate limiting because I have this set to local rate limiting to be very, very low, that I'm only allow one request per 4 minutes. So I'm going to change that to a little bit higher. Look, I also got distribute tracing as part of the request. And this should be the request that just come in with 429. For those of you not familiar, that means the request is being rate limited. So you can see through agent gateway from my application to the large language model, I'm getting rate limiting as well. One more thing I want to show is as part of my application, I want to kind of analyze the mood of the audience. So I'm going to try to put you all on stage if I'm successful. Let's see if I got this working. All right, looks like I was able to put you all on stage. Now, show me some of the mood you have, hopefully. Yes, yes, awesome. I'm going to take a picture. And I'm going to rely on Ollama, a lava model, which I loaded to analyze.
Event taking place in auditorium. Focused audience facing stage with speaker. This is cool.
All right, just to recap, to show you what's just happening. So I was able to show you Agent Gateway as an ingress to my demo application. I was also showed you Agent Gateway as an egress to connect between my demo application to my external Ollama running outside of my cluster. I was also showing you Agent Gateway between my AI reliability agent to my GitHub MCP server. So this effectively is Agent Gateway in 3 different ways: as ingress, as a gateway between AI agent and MCP server, as an egress to large language model. What I haven't shown, which Agent Gateway can also do, is as an inference gateway. In fact, we just passed the compliance test of a Kubernetes gateway inference extension. That was the end of my demo. Thank you so much for having me.
All right. Love the brave folks that come out and do live demos, and great to get a little peek of the future, the agentic future. And I should mention, by the way, that Agent Gateway open source project was just donated to the Linux Foundation this week. So we're excited to be helping in building these communities. And the last 3 points I just want to leave you with is that training, inference, and agents are 3 key pillars. We have some different problems to solve in each of these different states of progress, and we're really invested in building strong communities. And strong communities will ensure that open source wins across the whole AI native stack. And the Linux Foundation is the place where we're doing a lot of this work, and we're committed to supporting many other projects and doing whatever it takes to make sure that the future of AI is, in fact, open. So let's build it together and connect, and let's work on this stuff. Thank you.